Hello, good day to all. So today I'll be presenting a report entitled Protein Tyrosine Phosphatase Receptor Delta serves as the Orexigenic Asprosin Receptor by Mishra I et al. But before that, let me first introduce myself. I'm Donna Piramada, a junior chemistry student of the Visayas State University. I'm 21 and I'm from St. Bernard, Southern Leyte. This article was published last March 16, 2022, and it was released in Cell Metabolism webpage just last April 5, 2022. So before we go on to the article, there are some terms that we should know. First is asparsin. So it's a protein hormone produced by mammals that stimulates the liver to release glucose into the bloodstream. It works by binding a protein on the neuron surface called a receptor, and then the AGRP, or the agouti-related protein, expressing neurons in arcuate nucleus of the hypothalamus. It's a key orexigenic neuronal population that increases food intake behaviors in response to homeostatic need. And then we have the PTPRD, or protein tyrosine phosphatase receptor delta. As said, it's a receptor of asparsin. And then orexigenic is a term used to describe a drug, hormone, or compound that increases one's appetite. So it's an appetite stimulant. In 2016, researchers at University Hospital's Harrington Discovery Institute and Case Western Reserve University, namely Elam Mishra, Wei Roxy, Juan Burnett, Tan Lin He, Yong Shu, and Atul R. Chopra, discovered a hormone called asparsin, an appetite hormone. It increases blood glucose levels by acting on the hypothalamus and the liver. Then just this year, the same group of researchers investigated using a mouse model study in developing a drug to treat metabolic syndrome by identifying a receptor that controls the appetite and body weight. So since the discovery of asparsin, many studies have been conducted, and it has been found out that asparsin levels are elevated in patients with metabolic syndrome, leading to weight gain and high blood sugar. Using mass spectrometry and by genetic deletion of PTPRD in mice, it has been discovered that low levels of PTPRD reduces one's appetite. Therefore, PTPRD is needed for the asparsin-mediated appetite stimulation. A receptor is necessary for a hormone to work, and for this case, PTPRD acts 1 for the asparsin hormone. Before, the identity of the receptor that allows the asparsin to activate AGRP neurons and stimulate appetite was unknown, and it acted as a great barrier to fully understand how the hormone asparsin works, but now that's not the case. So shown here is the graphical abstract of asparsin PTPRD mechanism. In figure A, the asparsin hormone goes into the AGRP neuron through the blood barrier, that little ones in yellow color. Then it is received by the receptor PTPRD, raising the AGRP neuron activity, thus increasing also the appetite of the person, which means that food intake and the body weight are also raised high, elevated. However, in figure B, the adipose tissues, there are already PTPRD LPD sequestered asparsin, so meaning only a few number can pass through the blood barrier to be received by the PTPRD receptor in there, which would result in a strong loss of appetite, lowering the food intake level and as well as the body weight of the person. To summarize my report, there are 4 key points to remember. First is protein tyrosine phosphatase receptor delta is the orexigenic asprosin receptor. Then PTPRD loss results in appetite reduction and unresponsiveness to exogenous asparsin. AGRP-neuron-specific PT-PRD ablation lead to protection from diet-induced obesity. And lastly, the PT-PRD ligand binding domain function as an appetite-suppressing therapeutic. This new discovered treatment is a holy grail for those who have body issues, but let's take everything lightly in moderation, because too much of everything is bad. It can cause more harm than good to your body. And that would be all. I hope you have learned something. Thank you everyone for listening, and have a good day.